Welcome back, everybody. An apology may be in order. I don't know. Yeah, that's good to see that there's students here this time. I think I opened the wrong link and did my intro there. It's a nice intro. You'll be able to see it. And it talked about hydrogen bonding, dipole-dipole attractions, and London forces, and branching. But I'll bring up each point as they come up in the question. And it's the spring 19 question. And here it comes, I hope. There we go. Got my Zoom in the way. Spring 19, test 1, part 4. So in my introductory remarks, I told you to look for molecules that can do hydrogen bonding first. Those are molecules like carboxylic acids with the strongest possible intermolecular forces, and alcohols, which are a close second, but they're second. So do we see any of those two functional groups in our examples here? And the answer is yes, I see both. I see a carboxylic acid in Roman numeral VII. And it's a pretty big molecule. Typically in these questions, I choose molecules that are not that different in size because I'm trying to keep that variable to a minimum. But size is very important when we get to the London discussion. But this guy here with 8 carbons and 2 oxygens has a carboxylic acid. It will be top dog, and we will explain why right now. VII has strong, that's a weird the strongest H bonding. And from now on, instead of saying H bonding, I'm just going to say HB. I just want to point out, if you show up on the test and write HB without ever defining it, I'm going to have to take off at least a half point. I know what you're trying to say, but in science, if you're going to use a short form, in any subject for that matter, if you're going to use a short form, you must define it before you use it. There we go. And then the VI has HB as well, but not as strong. That's already implied with my first statement. And then the next strongest hydrogen bonds are found in primary or secondary amines, and also primary and secondary amides with a D. Those are the nitrogen-containing functional groups that can hydrogen bond. Notice I did not include tertiary for either category because they do not have H bonded to N. So I'm putting V next. V has NH, weaker H bond. Okay, so that's those. I like to cross them off as I finish with them. So I've done that one, and I've done that one, and I've done that one. And now I'm looking for dipole-dipole molecules. In our introductory video, which when you see it, you'll see that I discussed the other carbonyl functional groups, not carboxylic acids or primary and secondary amides, but ketones, aldehydes, esters, and tertiary amides all have a carbonyl, but they can't hydrogen bond. But they'll be underneath the hydrogen bonding ones. This one is an ether. Ethers are remarkably nonpolar. There's no hydrogen bonding possible. When you see an ether, treat it like an alkane. That's a hydrocarbon. This one has an ether here and a ketone. Ketone. Ketones have dipole-dipole attractions because they are polar covalent bonds. So 2 has ketone. I'm circling the ketone. Verify that can't be an ether with a Lewis structure if you need to, which has dipole. Now, if I use the short form IMF, you could say that's the International Monetary Fund, and that would not help you at all, right? No, here I better define it up here. Oh, that didn't work. Intermolecular. There's your IM force. This IMF. There you go. And we have another functional group that's got a dipole intermolecular force, and ethers don't. And my 3 remaining molecules are ethers only, hydrocarbons, and hydrocarbons. So the dipole attraction discussion is over. And now we're looking at London only. So I better put my ketone in its proper place and then move on to London only. LO. The molecules with London only are 1 and 3. And we're finished with 2 and 4. Now it's time to look at their masses first. Any larger molecule that has the same intermolecular forces will have a higher boiling point than a smaller molecule. And remember, ethers are non-polar. So pretend the O is the same as a C for doing like a rough molar mass estimate. I'll call them heavy atoms, carbons and oxygens. And if I had a nitrogen still to talk about, I would count nitrogens as well. So heavy atoms, I'm going to just count in green. This one, 1, 2, 3, 4, 5, 6, 7, 8, 9 heavy atoms. This one, 1, and then 4 in a row is 5, 6. Branched one is 7, 8, 9. So they have very similar mass. And this, they all have 9 heavy atoms.
Can you repeat how did you count 9 for 1?
I'm counting carbons and oxygens both as heavy atoms. Maybe I just counted, I don't know. 1, 2, 3, 4, 5, 6, 7. Thank you. You caught me. I'm glad you did, because I was about to have trouble explaining why these and they could be different. And now I know why they're different. Good catch, thanks. Yeah, 8 heavy atoms. 1, 2, 3, 4, 5, 6, 7, 8. So that is going to be the loser. He's the smallest molecule that has London forces only. And write that down. 1. Smallest molecule with LO. London only. So he's done. I'm liking it. Trying to get my pink pen. I forgot I'm not supposed to be on the very bottom of the screen at home, and then I'm doing weird stuff. I'm rusty here. Rusty. There you go. Not at the bottom. I'd be able to get my pink now. Cross it off. That's 1. Now, of these 2 remaining, I think it's clear which one is branched. And that would be the one with the methyl sticking off of the chain. And this is just a chain. Please verify CH2 7 times is 7 carbons in a row. That's what CH2 in parentheses always means. So that's a straight chain called nonane. And this one is an octane. You want me to count to 8 for you? 1, 2, 3, 4, 5, 6, 7, 8. And then off of 3, there's a branch. So 3, oh, wrong color. 3 has more branching than 4, and that causes the London to go down, causes BP to go down, so 3 will be lower than 4. I don't like the way that worked out. 3 will be lower than 4. And that is the end of that answer. But I want to see the whole thing. I pretty much have everything, don't I? Yeah. So this would get full credit. What does it say? The explains 5. I'm debating just making the explain worth 6. There's a lot of explaining. But I will not make any major changes to the test. If you see the point count on the original test, I'm not going to change it by more than 1 or 2 ever. Okay? So that's the end of this. Does anybody have a question about this one?
Professor, where can we read about this? And which section of the book?
The one that talks about intermolecular forces, and it's, well, let's go find the table of contents if we can. And I'm just zipping on over here. Table of contents. 1, 2. I'll move it. Should pop up over here. Should. All right. Okay. So where do you think we're gonna talk about? Yeah, physical properties of alkane. Isn't boiling point a physical property of an alkane? A boiling point period is a physical property, right? And here we're talking about densities, solubilities, and boiling points. So there's your answer. You want to read about it in section 2.4. And then find, there's at least one video. There's probably more. If you find the one video, anything with 2.4 listed as the section, and then any problem that has like boiling point in its title, any video that has boiling point in its title. That's what you're looking for. So I think there's going to be several resources. And we find those on our list of videos. That's at the top of Moodle, right? So we okay with that?
Yeah.
Okay. So why doesn't somebody give me another problem to do, and then I'll stop the video and I'll set up that problem while I'm stopped, and I'll be right back. Sound like a deal? So what's our next type of question you want to do? A specific question is best.
And we do number 6, or go ahead, whoever was speaking.
No, go ahead. You started.
Number 6 is a good one, but I just wanted to bounce off of the one we just did.
Okay.
There's one that asks about the combustion. It's like a combustion reaction question.
This one?
And when combustion,
Yeah, right here.
it's part 4 in winter 21, question 3.
Oh, am I not sharing the screen? Oh, question 3.
And
Wrong test, winter 21.
It's winter 21 test.
I think I still have that open from before. I wish it would show me the title. Why are you not showing me the title? I gotta go down here to see if it's winter 21. And it's winter 19. I don't have winter 21 open at all. So you want me to do winter 21 when I come back, and it's question 3 short answer?
Yeah, it's part 4, and I think she wanted, I said question 3, and I think she wanted question 6.
3 and 6. I'll get them both set up and I'll be right back, okay?
Okay, thank you.
All right. Adios.